As said, really enterprise-like project, and we went and adopted AWS with cloud nativity, so whatever we could get as a service. And we went for a few methodologies. So we went with GitOps and domain-driven design, and event sourcing, and CQRS, and monorepo. In the backend, we have Spring Boot and Kotlin with a microservices-ish setup. So eventually 1.3, I would guess, microservices, but microservices ready anyway. The frontend is made of React and JavaScript, and the end-to-end testing is done with Spring Boot and Cypress.js. Let's see, what is GitOps? So GitOps is a buzzword. It's buzzing a lot in the last 2-3 years. And as every buzzword, it has a lot of different interpretations and definitions out there. For me, it's basically a pattern for application lifecycle development and infrastructure provisioning. And my favorite definition is from a guy here called Luis Facera, and he's saying that GitOps is those three things. So continuous everything. Git is the single place where we operate. So continuous everything, we had first continuous integration. We started building our artifacts automatically and testing them. And now we have continuous deployment and delivery. And now we add to it Git, let's say, continuous provisioning. And the whole thing together is continuous everything. So Git is a single place where we operate. It means we are not doing stuff from a shell or SSHing to some machine or doing anything like this. There is a continuous provisioning system. We push to Git, and the things happen. And Git is the single source of truth. So there is no additional truth. Someone went to the console and provisioned something, etc., or someone did anything from the shell. What you see in Git is hopefully what you have provisioned in the cloud. And all changes are observable. So that's also very important. And this is a place where maybe our implementation could achieve a little bit growth. The second subject I wanted to spotlight is the AWS-CDK. So the CDK is a framework and CLI from AWS, which simplifies infrastructure provisioning. And the framework was launched in 2019, and it's gaining a lot of traction and adoption. And it's also becoming a community that's outside of AWS. So HashiCorp also adopted Terraform and their CDK, and they are building a Terraform CDK. And there is another CDK for Kubernetes. And there are many other like fringe CDKs, so people creating stuff around this. There is also, the community has the CDK day, so there is a lot of movement around CDK generally. What is it actually? It has, in my opinion, 5 principles. And the first one is that it meets the developer in their own programming language and IDE. So you have all the capabilities and wealth of features that a modern, let's say not Python, programming language has, and all your IDE capabilities. And CDK is currently available in TypeScript, JavaScript, Java, Python, .NET, and Go. So a really nice selection. And then CDK, it leverages statically typed languages. So this interacts with the first principle a lot. So in CDK, you don't now enter as a value for an EC2 instance. I want it C6.large, and then find out in provisioning that it does not exist. You will need to set a proper definition. And you can use your IDE to do that. You can see if you made something wrong, hopefully with an underline in your IDE, or in the worst case, on compile time, but almost never on provisioning. Yeah, so CDK, it provides and supports many abstraction levels. So additionally to the abstraction capabilities that your programming language has, CDK has 3 levels called L1, L2, and L3. And in the highest level, you have things like one construct, so that's something that you can provision with 3-4 lines that provisions you a whole automatically scalable cluster of Docker containers that consumes a queue and auto scales according to the queue size. So that's a lot of functionality, and we actually had in the company one time where this was useful. But naturally, if you does not fit you this level of abstraction, you can go for a lower level of abstraction and still be productive with it. Then another principle is that CDK always or almost always provides same defaults. So you can provision, I don't know, a VPC with all of the subnets and the internet gateway and the routing tables, etc., with very few lines of code, and use the defaults that are existing there. And you can customize it if you need. So CDK really enabled us in the last project, so it's very recommendable to give it a try, and I really recommend cdkworkshop.com. It's a good entry point for this AWS-CDK. So let's talk about GitOps in practice. So GitOps, it's really tightly coupled with testing. If you just whatever you are committed will be automatically provisioned, it will be very, very easy for you to break production. I don't see a big upside to doing GitOps without being able to really test the whole thing and have a few environments and stages so you don't break production. And you cannot GitOps all the things, so everything has to start somewhere, and in this case, the start somewhere is a developer and a shell, and it's also very, very challenging to GitOpsify everything you want. So you have to group some sort of scopes which you will work with GitOps, and a few things in your life will also still be provisioned the old manual way. And when working with GitOps, when it's something small, we just make the changes, commit it to Git, and it's automatically provisioned. But when you want to develop really infrastructure and bigger pieces, it's really helpful to have some sort of an ad hoc environment that you can from local work and massage a little bit until you are happy with it, and then you can, let's say, commit it and have it pass your whole automated testing process. So let's look what we did. I know you cannot see much here because the diagram is really small, but this is all of what we built this year, and it's about 600 resources to provision. Not all of them are in the diagram naturally. And the stuff on the top with the white background, those things are not GitOps wise. So this is all kind of supporting domains and the CI/CD, etc. All of these things are happening from the shell and being provisioned. But below the green part, this is our core and our, let's say, GitOps scope that is testable, and this is our actual application. And for this, we have many environments. So in this diagram, we have end-to-end staging and production. In reality, we have more, but this is our GitOps scope that is being continuously provisioned. And this is how it looks when it's zoomed in. So we have here a stack of around 120 resources. We have some event buses. We have some Spring Boot Fargate containers, and we have DynamoDBs, we have SQL, we have application load balancer. Not really helpful to get into the details here, but it's quite a lot, and there is quite a lot that you can break in the integration of it. So testing really goes a long way here. So let's see how GitOps and AWS-CDK play really well together. So we have this scope of GitOps, this green thing there, and this is basically a class. So we are able with TypeScript. Is there anything that you cannot hear me?
No, we can hear you.
Okay, someone wrote that it's off and on. Okay,
yeah, that was some minutes ago. All good.
Just appeared. So it plays really well together with GitOps and AWS-CDK because we can take this green scope of GitOps and we can put it in a class, a TypeScript class, and this class encapsulates the whole logic and the whole resources that have to be deployed, provisioned in order to achieve this stack. So you can here put some type of the stage. So we have test and production in this example. And then everything is well encapsulated inside it. And the result is very expectable. And there is really a good match between the environments are very close to each other. They are almost similar. So let's see how our pipeline works. So we are using AWS code pipeline. And first we fetch from Git. So we said monorepo, we have only one source, very easy. And then we have the build and unit test stage. And in the past, we had here, we would have had here a backend build, which builds a Docker image, and a front end, which builds some package. But now we are doing GitOps, and we have also an infrastructure stage. And in this stage, we basically create, and we can also unit test the infrastructure artifacts. So we treat infrastructure the same way as we treat front-end and back-end code. We create artifacts here, and they are pre-generated here and then used later. So they don't differ if something in the universe or something has changed afterwards. It's not like when we deploy to prod, something can change really. Of course, someone could have manually made something, but generally it's very expectable, the results that you get in this way. And then we take the artifacts here, infrastructure, backend and frontend, and we continue with a pipeline. And this is our end-to-end stage. And this is the core of our testing. So what we do here is we destroy the whole green GitOps scope here, and then we redeploy it. So we get it fresh and clean, and we are not, we don't have too many blinky tests and stuff because it's always in the same clean state. Then we deploy the other artifacts, the backend and frontend, and then we run two end-to-end test suites. And the more interesting one is the backend test suite, and that's Spring Boot based. And this transitively tests all of the infrastructure. And it also tests how the infrastructure is interacting with the backend. So how the service discovery is working together with these things, that all the functionality is there. Now, I wish that we had also more explicit infrastructure testing, but we never made it in the project. But the thing is transitively very well tested. Then we have a front-end test, so that's Cypress.js, and it also transitively tests some things like the CDN and the front end of the application, etc., and how it interacts with the backend. And when we are sure that the whole specific current commit in the monorepo with the infrastructure, backend, and front-end changes is working really well, we can go to Staging, we first provision the infrastructure artifacts, and then we can deploy to this infrastructure, the backend and front end, and then we go to production. So that's generally our pipeline. What are our learnings? First of all, monorepo in such a constellation where it's one team and a limited project that is not going to grow and scale, etc., was really great. So you have one change set, one commit that is deployed to the infrastructure and to the front end, to the back end, and it's very observable what is currently deployed to each stage. And finding root cause of things is really, really easy this way. And then this environment with GitOps and CDK and the abstractions, it really helps in some situations. So at some stage in the project, we were developing really intensively, and there were a lot of times that the main pipeline was broken. And it was broken because of end-to-end tests that were failing. And then we said, what can we do about it? And it was very easy to assemble from the CDK code a per pull request environment. So every time we open a pull request now with a feature slash name, we get a whole GitOps scope, the whole application being deployed to a real environment. And we get a whole pipeline that is the same as the other pipeline, just doesn't have staging and production. So it has only an end-to-end. And then we can merge and know that there is really a really good chance of us passing through the pipeline. Then GitOps worked really well for us. So I don't think we broke production in this project in no stage. And it's a project where you can break production, so it's internal. It's not. It has very few users, so wouldn't be the end of the world if it's a little bit broken. But it never really happened. So GitOps provided us a really great safety net. Lastly, I wanted to go over a few challenges we had and how we coped with them. So CloudFormation provisioning time is a pain point. So the pipeline can destroying the whole stack and reprovisioning it takes anywhere from 10 to 17 minutes, which is a little bit too much time to wait. Would have been really great if AWS improved that. We found a few workarounds here. I won't dive deep to them, but you can improve it a little bit. An additional issue was some sort of limit exhaustion. So we had, there are very specific resources that CloudFormation actually retains if you delete the stack. So that's an example at the RDS-DB subnet. And very fast, we reached our 40 or 50 limit in the account. And we had to tweak this so you can use CDK to tell CloudFormation, hey, deletion policy here is delete. And after a few iterations, we had no issues with this. Then costs. When you have 3 always running environments and additionally pull request environments, and all of them are really fully featured instances of your application, costs are to accumulate. And we built a nice Lambda function, just destroys those stacks in the night. So they are destroyed in the night, and then when they're coming another commit, they are reprovisioned. So they might be for the whole weekend down, or they might be for a whole week down if the pull request is not very active. And then in costs also, serverless services really helped us. So being able to use something like RDS serverless with a pay-as-you-go model, it means that you can have the whole thing testable. So end-to-end and production, they are using the same database and same configuration and same thing. But as prod is active and end-to-end is not, then prod is costing more money and end-to-end is costing almost nothing. So that's also something that helped us. When you have the full capability of a programming language, what happens is that you can create dependencies. And CDK has a way to handle those dependencies, but you might also create circular dependencies. And you have to learn to work with this. So there are a few workarounds or a few mechanisms that you can build into your CDK code to improve that. And then another thing that is a little bit missing is kind of observability around the changes that are happening. So we do have it in our logs, but we don't have something that we can actively work with. So that's something that we have to improve, that in some situation you can see something like, it's called a change set in CloudFormation. So what is actually going to happen? So because there are some cases where you are not really sure that your tests are grabbing the whole complexity of it. So that's something that's on the roadmap. Yeah, so that's it. Sorry for the technical issues. And I'll be really happy to, if anyone has any questions. And I pass the time a little bit, there are a lot of time. So if there isn't time, then we can also continue questions and discussion in the community, in the tech chat cloud DevOps channel.
Perfect. Thank you, Tom. So we have time for questions. Are there questions for Tom? I see a lot of applause. I don't know if you can see it, Tom, but everyone is clapping hands, sending clapping hands. And Jonas has a question, I think.
Yes. Hi. Hey, Tom, thank you so much. I actually use CDK quite extensively for a private project, and I absolutely love it. Thank you so much for the CDK DIA or DIA. I was sort of looking for something similar, actually, so thanks a lot for that. I was wondering about the deletion policy, because I ran into similar issues where essentially you destroy didn't cleanly, get rid of everything, but always left something behind. Do you have to specify that on sort of every construct that you use?
Yeah. So if you look at the CloudFormation documentation, you see that for each resource there is a default behavior. So something like an EC2 instance will usually leave after it a snapshot. Something like an SQSQ will just be deleted, and something like an EBS volume, I'm not sure what is the default, but it comes out of same defaults to prevent people from deleting their database and stuff. But yes, you have to define it per construct. There is also, technically, CDK has some sort of aspect-oriented programming support. So you could be able also, if you really want to do some AOP action, you could be able to do something like this. Yeah, it's a possibility though, yeah.
Okay, I'll check it out in the documentation. Thank you so much. And then two more questions, if I may. First of all, I was wondering about testing, if you sort of tried out any sort of unit or integration testing, and also why did you use code commit actually instead of sort of just integrating that in the GitOps build step?
Well, testing. Generally, CDK has some sort of a jest module that you can add tests. Those tests are mostly testing that the CloudFormation synthesized stack is as expected. So when you are writing stuff that is low level, it's a good idea to test. I have some construct I wrote, and there it was a good idea. In our project that you are using stuff that is already tested, I'm not sure that it's really a good use case. I have seen that people are doing, there is from Chef some tool, I forgot the name of it, and people are doing some sort of infrastructure tests with these. But you can also do it with Spring or JUnit or whatever you wish. So we have a really extensive suite in the backend end-to-end. And we test the functionality, and also Spring will just not bootstrap if something is not something that it expects is not available there. So I'm relatively I have a good safety net that I know that it's really hard to break, but I wish there was more explicit testing. And yeah, so that's your first question. What was the second question? I forgot.
I was also trying to choose between code commit and just running sort of a Docker container in the GitOps environment to build and update everything on AWS. I was wondering why you chose code commit over just sort of doing that on the GitHub side.
I know we are using GitHub. So we have a trigger on GitHub, and we are definitely using. So the repository is on GitHub. You can see here. So. Yeah.
Oh, but it builds in the cloud essentially.
The building itself, well, that's happening in code build. There are a lot. I think the AWS code build is really much more flexible than GitHub Actions. You mean? It provides a lot of yeah. It's just you can tweak it a lot. So, an example, we have our build step inside the VPC that is connected to the Axel Springer network. And that's something that, and we use resources in the Axel Springer network. That's something you wouldn't be able to do, I think, in GitHub. I don't know it thoroughly. And then, yeah, cloud nativity. I mean, permissions work flawlessly. So the whole thing is very, very easy to work with. Naturally, one could use good GitHub Actions, of course. Yeah.
Cool. Well, thank you so much for all these answers.
Maybe adding one point, we are using GitHub Actions actually in our own Kubernetes clusters. So we are inside the Axel Springer network, and there are no boundaries at this point. So it's possible. We are using in a lean team.
Cool.
If you are interested in, I think Jonas, not Peak, the other one is the right one for you.